Module 9, Section 7.4, Permutations and Combinations. Objectives: be able to set up and compute factorials, be able to apply and calculate permutations, be able to apply and calculate combinations, and finally, solve applications involving permutations and combinations. Definition of n factorial. N factorial is equal to n multiplied with n minus 1 multiplied with n minus 2 multiplied and so on all the way up to 1. Here is an example. 5 factorial is the same as the product of 5, 4, 3, 2 and 1. When we multiply them all, we will get 120. Exactly the same way, if we want to calculate 8 factorial, we can write it as 8 multiplied with 7 multiplied with 6 multiplied with 5 multiplied with 4 multiplied with 3 multiplied with 2 multiplied with 1. So this product is going to be the answer for 8 factorial. We also notice that if we group the last factors except 8, we can write this also as 8 times 7 factorial. So which is what we have written here. N factorial can be written as n multiplied with factorial on the lower number, n minus 1 factorial. By definition, 0 factorial is always taken as 1. And most calculators have an n factorial key. Here is an example. Let's calculate 4 factorial. 4 factorial will be, per definition, 4 multiplied with 3 multiplied with 2 multiplied with 1. So we get this product to be 24. So that is the answer for 4 factorial. So if we want to divide 7 factorial with 6 factorial, we can write 7 factorial as 7 multiplied with 6 factorial. Then we are dividing with 6 factorial. So the 6 factorials will cancel off, getting 7 as the answer. 13 factorial over 10 factorial. So it can be written as 13 times 12 times 11 times. Then the remaining factors can be written as 10 factorial then divided with 10 factorial. So notice that when we reduce this, 10 factorial cancels, getting this as the product of 13 times 12 times 11. And that number comes out to be 1716. So in this last example, 600 factorial divided with 598 factorial. We do the same kind of simplification. 600 multiplied with 599 multiplied with 598 factorial divided with 598 factorial. Cancellation. So this answer will be 359,400. This example we are going to use the calculator to compute the factorials. So to calculate 8 factorial, 8 followed by the factorial notation, math, right arrow, come under probability, scroll down to 4, enter. So this will be 8 factorial. If I press enter again, I will get the answer 40,320. To do the second problem, I can use the factorial again. So we do have 9 factorial. So that is to be divided with 6 factorial. So 6 math. So that is how you enter 9 factorial over 6 factorial. If you press enter, you will get the answer, which is 504. Here are 2 problems illustrating combinations and permutations. Problem 1. Consider the set P, E, N. How many 2-letter words, including nonsense words, can be formed from the members of this set if 2 different letters have to be used? So we are going to list all the possibilities. We are allowed to take only 2 letters. So we can have PE, PN, and then you can have EN, EP, and then you can also have NP, NE. This is a complete listing. So there is a total of 6 possibilities. Now in problem 2, we consider the set consisting of 3 males, Paul, Ed, and Nick. For simplicity, we are going to denote this set by P, E, N. How many 2-man crews can be selected from this set? To answer this question, we can select Paul and Ed, which is PE, Paul and Nick, PN, and we can also select Ed and Nick, which stands for EN. These are all the possibilities. Both problems involve counting the number of arrangements of the same set, taken 2 elements at a time without allowing repetition. However, in the first problem, the order of the arrangements mattered, since PE and EP are 2 different words. In the second problem, the order did not matter since PE and EP represented the same 2-man crew. We counted this only once. The first example was concerned with counting the number of permutations of 3 objects taken 2 at a time. So permutations will be where the order matters. Second example was concerned with the number of combinations of 3 objects taken 2 at a time. In combinations, the order doesn't matter. So we are going to use some notations. Pn, R represents the number of permutations of n objects taken R at a time, where R is less than or equal to n. In a permutation, the order is important. This notation Pn, R can also be written as P suffix n, R, and in calculator this will be denoted like this, N, P, R. So this is the calculator notation. In our example with the number of 2-letter words from the set P, E, N, the answer is permutation 3, 2, which represents the number of permutations of 3 objects taken 2 at a time. We got this answer to be 6. This is the permutation formula. P, N, R is the product of n times n minus 1 times n minus 2 times all the way up to n minus r plus 1. So that means we are multiplying R natural numbers here, starting with n, ending with n minus r plus 1. A numerical example will be something like this. P 5, 3, which is the number of permutations of 5 objects taken 3 at a time, will be start with 5, which is our n here. Then you keep on multiplying with the next lower integers. 5 times 4, that is n minus 1, 1 less, and then 3, and you stop there because we need to have exactly 3 factors in that product, 5 times 4 times 3. So the answer will be 60. So the value of P5, 3 is equal to 60. This is another way of writing that. The number of permutations of n objects taken R at a time is equal to factorial n divided with factorial n minus r, where r is something between 0 and n. Find the value of P5, 3. So we are going to use this formula, factorial n over factorial n minus r. So this will be then factorial 5 divided by 5 minus 3 factorial. So when we simplify that, we'll get 60. This means there are 60 permutations of 5 items taken 3 at a time. So we are going to use the calculator to find P53 also. Remember that I mentioned in the calculator this will be using this symbol. 5 is first, and then you need to have the symbol NPR. This is the calculator key, and then use the R value as the next number. This is the way you enter this. So we are going to calculate P5, 3. So the first number will be 5. Go to math. Go to probabilities. Permutation will be the second item. Call that NPR. Enter. And complete it by putting the value for R, which is 3. Then if you press enter, it will compute 60, which is our answer. It's an application problem. A park bench can seat 3 people. How many seating arrangements are possible if 3 people out of a group of 5 sit down? Think of the bench as 3 slots. So we have 5 people who needs to be seated. So the 5 possibilities will be here. Then we have 4 remaining. So any of the 4 can be seated next. Any of the remaining 3 can be seated next. So the answer will be, using the multiplication principle, it will be 5 times 4 times 3, which will be equal to 60. The answer could have been found using the permutation formula P5, 3 equal to 60, since we are finding the number of ways of arranging 5 objects taken 3 at a time. Objective 3. Combinations. In the illustration problem, the number of 2-man crews that can be selected from the set P, E, N was found to be 6. This corresponds to the number of combinations of 3 objects taken 2 at a time. Also written as C 3, 2. C stands for the combinations. P stands for permutations. This is another notation of the combination. And again, in the calculator, this will be written as N, C, R. This is the calculator symbol. Here is the formula for the number of combinations of n objects taken R at a time. C n, R is equal to factorial n divided with factorial R multiplied with factorial n minus R. Remember that for combination, the order of selection does not matter. Here is an example how you use this formula. Suppose you want to calculate C6, 2. So C6, 2 will be n value 6. So factorial 6 divided with R value is 2. So it will be factorial 2 multiplied with n minus R will be 6 minus 2. 6 minus 2 is 4. So the second factor will be factorial 4. 6 factorial divided with factorial 2 times factorial 4. So that is what this formula stands for. So a few questions. We need to calculate the number of combinations of 8 objects taken 5 at a time, or C8, 5. C8, 5 equals factorial 8 over factorial 5 multiplied with factorial 8 minus 5. So when we do this arithmetic, we will get 56. So in the second example, R value is 8. Here we are speaking about the number of combinations of 8 objects taken 8 at a time. So when we substitute in the formula, we will get factorial 8 over factorial 8 times 8 minus 8 factorial. Notice that we get 0 factorial here, but we define 0 factorial to be 1. So the final answer will be factorial 8 over factorial 8 times 1, which will be 1. Now using the calculator, so we need to find C8, 5. So in the calculator form, that will be 8, then the calculator symbol 8 NCR followed by 5. Then if you press enter, you will get the answer there. Let's do this in the calculator. We have 8 first. Go under math, probabilities. Combination will be the third item, so we need to scroll down to 3 and then complete that by putting the value for R, which will be 5. So this is going to be 56. For the second one, we need to divide 2 combinations. So I can again do 35 So this will be the numerator. So divide that with combination 19, 4. So that will be 19 first. Math. 7544. Permutations or combinations. In how many ways can you choose 5 out of 10 friends to invite to a dinner party? Does the order of selection matter here? If you choose friends in the order A, B, C, D, E or A, C, B, D, E, the same set of 5 was chosen. So we conclude that the order of selection does not matter. So our answer will be combination 10, 5. So that comes out to be 252. How many ways can you arrange 10 books on a bookshelf that has space for only 5 books? So we are speaking about arranging books on a shelf. So the arrangement will be different depending on the order in which the books are placed. So this time the order matters. So therefore the answer will be permutation of 10 objects taken 5 at a time, or permutation of 10 books taken 5 at a time. So that number will come out to be 30,240. It's an application problem. In a horse race, how many different finishes among the first 3 places are possible if 25 horses are running, excluding ties? So we are speaking about the first 3 places. First place, second place, third place. So the order matters here. We have 25 horses. Because the order matters, it is a permutation of 25 horses selecting 3 at a time. So P25 3 is the answer for this. When we calculate this, we will get 25 factorial divided with 25 minus 3 factorial. From a committee of 10 people, how many ways can we choose a subcommittee of 4 people? So we are speaking about selecting a subcommittee of 4 people, and subcommittee remains to be the same in whatever order we select 4 people in that. So the order doesn't matter here. So it's a combination case. So the answer will be combination of 10 people taken 4 at a time. C 10, 4. So according to our formula, this will be equal to 10 factorial divided with 4 factorial multiplied with 10 minus 4 factorial, which will be 6 factorial. If we put this in the calculator, we will get 210. One more example. An electronics store receives a shipment of 25 graphing calculators, including 3 that are defective. 5 of the calculators are selected to be sent to a local high school. If so, how many selections can be made using the original shipment? So we are selecting 5 out of 25. So the selection order doesn't matter. So it's a combination 25, 5. And that equals 53,130. How many of these selections will contain no defective calculators? Notice that there are 3 that are defective. So we have 25 total. If you subtract the defective ones, there will be 22 non-defective ones. So these are non-defectives. Defective total minus. So if you want to get a selection that will contain only the good ones, we need to select it from the 22 good ones. So it is again the combination 22 and then selecting 5 out of the 22 good ones. And this number will be 26,334.